I suppose we can go ahead and get started. Well, first of all, thank you everybody for taking time out of your day to join us today. I know times are tough and things are weird, but I appreciate you taking your time to join us for this presentation. On the agenda for today, once we get some introductions out of the way, we're going to speak about the landscape of 3D printing and manufacturing as it is today. And then we're going to speak about what Markforged has to offer as a platform and a process. We'll start with composites and then metal. I know there were some people interested in one more than the other, but we're going to go over both of them. And then we're going to jump right into customer case studies, examples of people who have found real value with the Markforged system in real world applications and seen real monetary success from it. So with that being said, nice to meet you. My name is Jack. I'm the marketing manager for Kearney Machinery. We're a machine tool dealer based out of Birmingham, Alabama. We've been in business for over 30 years, and we primarily deal in subtractive machinery for manufacturers across the Southeast. But we also carry Markforged because we find that it augments the process of a lot of the machines that we sell and is an excellent additive system to get traditionally subtractive shops into the zone of additive, and it makes a nice transition to that. So the materials that it prints in are very strong, and the parts that it makes are very functional. So it works very well with the other technology that we sell. So why am I here? I'm here to inform and educate you and give you some ideas on how you might integrate additive into your current process. How the goal today is for you to leave this presentation with a better understanding of where additive is today and what you can start looking for in your own workspace that might be augmented by adding some additive to your shop. So let's just jump right in. 3D printing has a broad impact to manufacturing organizations, perhaps more than you're aware of today. I know years ago, 3D printing was more of a novelty. It was something that hobbyists invested in, not manufacturers, although manufacturers may have found marginal uses for the technology. It was not thought of as something that could replace or help a real serious manufacturer in any way. And that's not really the case anymore. Today, we'll explore beyond the tip of the iceberg and share a number of examples where customers are realizing major manufacturing efficiencies and transforming their business with Markforged. So if we broadly look at what customers are getting from integrating additive into their current process, they see increased efficiency in several parts of their operation, namely increased process speed, often related to lightweighting benefits of additive, reduced downtime, so no for replacement parts, and then greater yield for the parts that they create, improving the design of their line to be more efficient. If we are getting, this means that they can lower their production costs, which is something every manufacturer is looking for, and it can improve your ability to compete. You can free up machinist talent because it's a different system, and because there's less tooling required to make parts, you don't have to occupy not only a machine but a machinist. So that machinist is free to work on the production line rather than R&D or on tooling. It improves profitability, like I said, because it lowers your production costs. You can get to market, you have greater margins because the parts that you're creating are hopefully cheaper with the advent of this technology. Shorter product development cycles, you can get to market faster by decreasing the cycle times. Faster changeover and production scaling, it gives you flexibility to create parts on the fly that you may not know you needed when you were planning the changeover. And it reduces the money spent on physical inventory by transitioning to a quote digital inventory model. You no longer have to keep shelves and shelves of tooling just to make low run items. You can now just keep an online repository of part files that you can print whenever you need to. So it reduces space and clutter in your own inventory system. So what does this mean in a real world scenario? Inventory goes from a lot of physical to digital. A lot of space taken up, like I said, for tooling moves to an online repository. Production costs goes from higher to lower if you can find ways to integrate additive. Manufacturing, some parts that you may have manufactured offshore because of the price, maybe mainly smaller parts, the price may be prohibitive to get it locally, which increases lead times. But with the flexibility of additive, some of those parts you may find you can print in your own shop, reducing that lead time to almost nothing in the cost as well. Logistics, again, you go from global logistics to the last mile. If you can make something in your shop that you were previously ordering, that means huge savings and a lot faster time to market for your customers and you. New product development, it reduces iteration time. So what might have taken 4 weeks to iterate on, say 3 iterations of one prototype with all the tooling and machining time, may go down to a week and a half or a week, because you can print overnight. You can iterate on your designs faster because you have functional prototypes. And then demand planning, it goes from uncertain to predictable. You sort of can look at what you're being requested to do and use your printer to help you with that. So don't just take our word for it, though. I want to show you a video of one of Markforged's customers, Caldwell Engineering. They make window panes and fixtures, and they have integrated both the composite and the metal systems into their process, and it's revolutionized how they manufacture. So I'm going to play this video. It should work. I did test it before.
At Caldwell, we make components that go into windows and doors that are sold around the world. We've used the Markforged printers to make everything from prototype all the way through low volume production pieces, tools, and fixtures to aid in manufacturing for assembly and/or test and measurement.
In the past, an engineer would need a part made, and I'd have to estimate how long it would take to machine that part. Some of those parts could have 40 hours of machining in them. Today, with the Markforged printers, an engineer will give me a drawing, and the first thing that comes to my mind is I want to use the printers.
This fixture to machine traditionally would probably cost 5 times as much and take 2 weeks to manufacture. I printed it in a day, and they were able to use it that same day.
This is a production assembly. This is a prototype assembly using both composite and metal 3D printers. This assembly allows you to tilt your windows in for cleaning. Having the ability to 3D print our own metal components has really improved our development process.
The similarities between what we'll print in stainless steel and what we would cast in stainless steel is just incredible. That's something we can get in 2 days in our own lab. The hardware we manufacture is what holds the window together structurally, and if that were to fail, it can mean a severe damage to a building and major disruption for someone's life. The strength of the 3D printed parts that we get off the Markforged machines allow us to put those parts through the same set of conditions that we would test a production piece. They're real parts that have actual strength.
In this highly competitive world, you need every advantage you can get to produce the parts, do your job, have a leg up on your competition in every single part of the business possible. And 3D printing is huge to help us do that.
Pretty cool, right? So you can see that it's really changed the way they do manufacturing. And we're going to revisit them a little bit later in the use cases section, talk maybe some more about the actual business impacts from a monetary standpoint. So, okay, we've spoken broadly about where manufacturing is in regards to 3D printing. Now let's speak about Markforged itself. So Markforged doesn't just offer a 3D printer, it offers a platform, which means it has competitive materials, a comprehensive portfolio of materials that are all made in-house, strength and accuracy to an industrial level. So you're not going to be relying on, hobbyist printers to do your work. Accessible and easy to use technology that is designed for manufacturers who may not have experience with additive, helps them integrate this technology into their current process with ease. They do a lot to make sure that the integration goes smoothly because they're aware that the technology is new. And that's a complaint with a lot of 3D technologies, that it is difficult to use and rather finicky, and you don't get precise, good results. So Markforged does everything they can to try to mitigate that. And then as a company, they're also a leader in innovation. They've created multiple printing processes from scratch, and they're also developing software for manufacturing. One software that they're developing is called Blacksmith. It uses the power of AI to increase accuracy through machine learning, and then it learns at the speed that you need it to. So I'll dive into that a little bit deeper, but if you have any more questions about Blacksmith, feel free to contact me after the show, but that's not really what we're talking about today. So if we break it down, the value that's added from Markforged is high quality hardware. So hardware that does what it says precisely and accurately, that you can trust. Industrial grade materials that are all made here in the USA, that are designed for industrial applications, that are chemically resistive, that are strong, non-marring, that work for what you want your parts to do. And then enterprise level software that's designed to make it easy to print from anywhere you need, and it makes it easy to manage users that are using your printers. The software is continually being updated, so it's enterprise grade. It shouldn't be a hassle to work with. That's kind of the goal. So if we break each of these down individually, talking about the hardware. So they started with the printer on the left. It's that one's called the Mark II. It's a desktop series model. It's already award-winning. And then you move up to the industrial series that delivers more build volume, faster printing, more advanced materials, and additional hardware that delivers even more impressive accuracy and reliability. And then there's the Metal X system, which the printer is in the middle, and then the post-processing units are on the side. It's an end-to-end solution to 3D print metal in-house, and includes the printer, post-processing equipment, the wash, and the sinter. So that's what the lineup looks like of hardware. Now, if we speak about the materials, so they have a full range of materials that stand up to industrial environments. Strong thermoplastics like Onyx. It's a nylon 6 carbon fiber blend designed to create great surface finish, strong parts, and chemically resistant parts. Only Markforged has the proven technology to reinforce with continuous fibers, and we'll get to that in a second. But it allows you to print parts that function like parts that would be made out of metal. It allows you to replace some aluminum parts with ample strength from your printed parts. And then there's also the metal printing, of course. All the materials are made in-house, and they are comparable to their machined counterparts. So if we take the technology and put it together, you can do some really special things. This is a gripper arm that was used to lift a casting into a VMC. The company that was the part that they were replacing, they had to keep a lot of replacement parts on hand in case this machine went down. They switched to the Markforged system. They are able to print these parts in a matter of a day or two instead of waiting 2 weeks on their lead time. And it's printed specifically for these pieces. You see there's metal contact points for wear resistance and higher stiffness and strength. And then the arm itself is made out of composites that are reinforced with carbon fiber, which allows you to have the same strength as the parts that they were replacing at a much lower weight and lower cost. So using both technologies together can produce some pretty amazing results. And then if we speak about the software, I'm going to let this video play so you can see what the software kind of looks like while I speak over it. But it offers more than just a slicer. It is also a part repository, and it has fleet management features. So all your parts are stored within Eiger, and it can be accessed from any Google Chrome tab anywhere, even on your phone. It lets you view your parts in 3D and decide where you want to lay your fiber. It lets you change infills. It lets you change wall and floor and roof thickness. There's a lot of customization to your prints, and then it's all cloud-based, so you don't have to use your own computer resources to do the slicing. It does it all for you, and then you can print from anywhere. So you can be at home, and as long as your printer is up, you can tell it to print, and it'll be there when you get it in the morning. So the frustration of wonky slicers is sort of a thing of the past with this system, and I can speak from experience. This is a really very easy to use software. So those who are worried about having to overcome the software hurdles of doing additive shouldn't be worried. Eiger has you in mind and can fulfill your needs easily. So I've spoken about the platform itself. I'm going to dig a little bit deeper into the technologies, first composite, then metal, and talk about what makes them special. So I guess I'll start by explaining Markforged is unique in that it's the only proven 3D printing technology that can print continuous carbon fiber. This is kind of a complicated concept, so we'll talk about something that's everyone's familiar with. You can think of this like rebar in concrete. The continuous filament fabrication uses continuous fibers placed in the thermoplastic to deliver unmatched strength. So you can replace metal parts with parts directly off a 3D printer. So what that gives you is, like I said, strength that is comparable to metal parts, durability in a lot of different ways. It's variable depending on which fiber you put into your parts. You're able to change whether it's more impact resistant or lightweight strength. And then the parts are the process is optimized for performance. It's designed to be lightweight and great for manufacturers. So breaking down the process a little more, you start with your part in CAD, design it just like you would for machining, and then you put it in the slicer. And if I haven't explained what the slicer is, you can think of it like the equivalent of CAM for subtractive machines. CAM does the tool pathing, slicing, takes your part, slices it into discrete layers, and then paths the head around those layers so that the printer can create the piece layer by layer, and then you print it. So like I said, in Eiger, you can alter how exactly your piece is made, altering slight attributes of it, including where the fiber is placed. So the continuous fiber reinforcement, you can see the part on the outside is plastic, and every other layer or however you set it, it will print a layer of plastic, and then it will print a layer of fiber, and then more plastic. So the part is actually inlaid with strong fiber that gives it a lot more strength than it would otherwise have if it was just normal plastic. That's what lets these pieces be so strong and good for functional applications. So if we're talking about the fibers themselves, this is a stress versus strain chart of the materials that we can print with. So we often get asked the difference between our technology and the other industrial printers that print ABS, and you can see ABS down here on the bottom. So Onyx is already slightly stronger than ABS, but then you start including the continuous fibers. So if we start with carbon fiber, it's the most sought after fiber to print with for its strength to weight properties. So if you see here, it's actually stronger than aluminum. Aluminum caps out down here between 400 and 500. The carbon fiber parts can actually withstand more strain than the aluminum parts, or than a comparable aluminum part. Fiberglass is the most cost-effective fiber. Customers usually iterate on their designs with fiberglass and then print with carbon fiber later. Kevlar, like what you'd make a bulletproof vest out of, it's highly impact resistant and won't break, and it won't deform quite as much as some of the other materials. And then lastly, we have high strength, high temperature fiberglass. So it's like the fiberglass, but it can endure more strength, and it also raises the heat deflection temperature up to 150 degrees Celsius, which is about 300 degrees Fahrenheit. So when you combine it with Onyx, you get a part that can withstand applied load at elevated temperatures for prolonged periods of time. Here's a video of a chain link printed in carbon fiber, and they push it to its breaking point. So 22,000 pounds, that sounds like a lot. If you don't know how much 22,000 pounds is, it's one unloaded cement truck, or 6 2009 Ford Tauruses, or 19 grizzly bears, or 1.6 T-Rexes, or 1,500 bowling balls. So a lot of weight. These pretty strong parts. All right, so that's enough for composite. Now we're going to move on to metal. I know some of you are interested in mainly that, so this part's for you. The Metal X 3D printing platform is a safe, cost-effective, and easy-to-use system that dramatically reduces lead time, costs, and maximizes gains across your organization. It's safe, affordable, and easy. For those of you that have investigated other metal 3D printing methods, you know that Traditionally, DMLS is the other option, and it is very expensive. Those machines cost upwards of $1 million. They require their own environments and operators. They are very hard to change over, very power demanding, and require post-processing to even get the parts off the bed. You have to use an EDM machine to remove the parts from the bed. So although it is an option, it is often cost prohibitive and environmentally prohibitive for most customers. That's why the Metal X was made. The Metal X is a fraction of the price and can offer similar results to these machines without all the environmental hazards. So some of the benefits of the metal 3D printing process: no tooling. So if you have a part that you need made out of metal and you're worried about how you're going to position it in the machine or what tools you're going to use or even the time it's going to take to configure everything, no problems. You simply put your file in Eiger, slice it, and print it. It doesn't have any pre-setup required, so you have more freedom with the variety of parts you create. It's automated, so although most post-processing or most manufacturing processes require continual human oversight to ensure successful outcomes, this does not. All you have to do is put the piece in, like I said, and it prints it. You can print it overnight, come in the next day, and it's finished. And then geometric freedom. You know, we're constantly aware of the issues that traditional subtractive machines have with, you know, where your tools can go and how exactly you're going to create things. And some parts are just impossible to create with traditional subtractive methods. Those barriers are lifted with additive. It allows you more complex geometry and more freedom in your designs because you're not bound by the same constraints that you were before. So this can add a lot of variety to your skill set or to your arsenal in what you can create. So the process looks something like this. You print your piece. Once it's finished printing, it's what we call green. You take the green part and you put it into this, what looks like a fryer, but it's the wash station. It uses an industrial degreaser to remove the wax from the parts, leaving them porous. So you have a part that is metal powder bound in plastic with porous holes. You put it into the sintering oven. And for those of you who aren't familiar, a sintering oven uses a combination of heat and pressure to cook parts. So it compresses the parts, vaporizing the plastic and compressing all the metal together. So your parts do shrink, but it's uniform and the software compensates for it. So you plug your piece into the software, it will compensate for any shrinkage that it'll undergo in the sintering process, leaving you with your nominal values at the very end. And then you remove it from the sinter, and then it can go off to any post-processing that you would do on a part made on a CNC machine. It can do heat treating or sanding or anything you might need to do to this part. You should be able to do it. It's not a special metal at that point. It's just what you get out of the billet. So if we want to watch the process itself,
Part comes out of the furnace, it's easy to remove. Unlike other metal 3D printing systems, this process does not require loose metal powder, resulting in a safer and more cost-efficient workflow. 17.4 stainless steel is loaded now. However, with a quick changeover, the system is capable of printing in stainless steels, tool steels, coppers, Inconel, along with several other materials currently in development. Once your part is finished printing, you'll get a notification. At this point, you can go to the printer, remove the part from the build tray, and clear the bed. Now we have what's called a green part. It doesn't really look or feel like metal. However, a large part of it is comprised of metal powder. Next step will be putting it into wash 1 for the debind process. The wash 1 removes the first stage of the binding material. A green part is taken from the printer and placed into the wash basket, which is then lowered into the solvent. Wash times will vary, ranging from a few hours to a few days, depending on the thickest region of your part. After that, it's now called a brown part and is ready for sintering. Let's go over to the furnaces. This is Sinter 2, a furnace designed for mid-volume production runs and larger printed parts. Sintering transforms a print from a lightly bound collection of metal powder to a fully finished metal part. First, the temperature ramps slowly to burn away the trace amounts of remaining binding material. Then, temperature ramps closer to the melting point of the material, allowing metal particles to start to fuse together to create a strong metal part. Markforged sintering furnaces use a carbon-free retort to ensure part quality and alloy composition standards are met for our finished pieces. Each run takes about a day and can be monitored remotely using the Eiger software. Once a run is complete, the setter tray full of finished metal pieces can be removed from the furnace. Once removed from the raft, these parts are ready for use. In the furnace, the layer of printed release material between supports and the raft and your printed part remains powderized. This allows the structure to be tacked to the raft to better control shrink and accuracy throughout the process, but also an easy release after sintering. At this stage, your part is fully sintered and ready to be used. It can be post-machined, polished, or otherwise processed as necessary for the final application, but in many uses, the accuracy and strength are good enough as is. It's ready for install. Check out markforged.com for more information about our simple, safe, and cost-effective method of metal additive manufacturing.
Awesome. So gives you a good overview of how exactly the system works and how easy it is to use. So if we go into the materials that are available, the primary material that we often print in is 17-4 stainless steel. It's a corrosion-resistant firearm steel. It's very lightweight and works great for most metal applications. You also have Inconel 625, which if you've ever tried to machine Inconel, you know that it's very, very difficult. It's a very hard super alloy that is very good at taking changes in temperature. It can go up to 1,000 degrees Celsius without deformation. Great for furnace applications, and we'll speak about a customer that uses it very well later. D2 and A2 tool steel, your standard stamping tool steels, very hard and both available in the Metal X. Then you have H13 tool steel, which is a high heat resistant tool steel. And then copper, it's actually a recent release, but you can print any kind of heat sink you'd imagine, as well as EDM probes and welding probes. So copper, again, very difficult to machine. Not a problem with the metal printing system. A great solution for if you have to make things out of copper. You can also print coils. So if that's something that your business does, you might want to look into this. Titanium and 316L are both in development. And I can say that Markforged doesn't release a product unless it works. So I've seen titanium parts and they look great, but they'll release it when it will work on every system all the time. So that is coming down the pipe for you. So stay tuned if that's your primary metal you're interested in. So after everything I've talked about today, I have included a link in the description of this webinar, and I will send a follow-up email to everybody here to download white papers on our site. There's the Markforged design guides for metal and composites, so you can kind of see what sort of parts work better on these machines and how to design for them. And then Markforged also has something called Markforged University, which is designed to help people who don't have as much information about additive or aren't as used to it, sort of become more familiar with the technology, where it's going, and how to use these systems effectively. Seems like I'm getting a question that I'd like to answer now. It says, can you go into the importance of being able to change the materials in the metal printer? Yeah, so like I said before, in DMLS systems, there is a build chamber that has metal powder in it. And as you know, metal powder can be very dangerous unless it's handled properly. On top of that, if you want to print a different material in that metal system, you have to change out the entire build chamber. So the benefit to the Metal X is it's just a spool. All you have to do is load the material in and click which material you like, and you can put any of the 6 material spools into the Metal X. No tool changeovers, no nozzle changeovers. You simply tell it which material it's printing and it'll print it. So you can print Inconel, copper, and stainless steel all on the same machine with no changeovers. So now I'm going to speak about some real-world customer examples of people who have integrated Markforged into their process and found a lot of use from it. So Caldwell, like we spoke about earlier, you can see down here all these parts that they've made for all their different window fittings. They're a family-owned operation that's been in business for over 130 years. They design over 100,000 SKUs, so they have a lot of variability in what they create. 3D printing is the first tool they go to in their toolbox since integrating it. They use printers for prototyping, fixturing, sales demos, and in-use parts. The business benefits are undeniable, and they're developing products faster and at a far lower cost. Something else I want to point out here is it's become part of their culture. Like I was saying earlier, it frees you from some of the geometric constraints that traditional manufacturing methods have and allows everyone in your organization to take advantage of it. Say you have an engineer that's really bright and has ideas on how you could do things differently, but he can't just take a machine off the line to prototype those ideas and experiment. 3D printing allows you to do that. There's a much lower barrier to entry to innovation. So you can put this in the corner of your shop, and if an engineer has an idea of something that could improve your process, he now has the capability to act on that. It changes how everyone in your organization thinks. Lean Machine. So Lean Machine is a Canada-based CNC fabrication shop. They have a composite printer and a metal printer that they use from one of their partners. The tooling costs and manual processes weighed down their ability to take on new jobs. So they built an automated sheet metal bending cell, and they can go from a signed PO to fabricating parts in 4 days instead of 4 weeks. The press brake tool and die were previously machined out of heavy steel, but with printed parts, they bend the aluminum wire clips with a better quality finish because Onyx is non-marring, so it's not going to scratch any of your materials. One of the other applications that they saw was end effectors for robot arms. They printed 17.4 grippers to be used by one of their robotic arms in the same sheet metal bending cell. Now they're utilizing their CNC machines 5 times less than before, and they think creatively about how to best design for additive. Overall, it led to a 5x, they used their machines 5 times less, and it led to a 75% cost savings in their end product. Another one would be Nika Systems. They're a Canadian customer that manufactures mining and cement lab equipment. They design these crucible clips that hold the samples that they need to put in their furnace, and they need to be able to reach extreme temperatures and then cool down quickly to produce the final sample. They previously outsourced the printing of Inconel 625 crucible clips, as the material can withstand temperatures of up to 1,000 degrees Celsius and then cool down without deforming. The high cost was getting to be too much, so they decided to bring in printing capabilities in-house. You can see on the left is left is the Markforged printed part, and the right is the DMLS part. So they look very similar. Insourcing also benefits businesses in a couple of other ways. Having the machine in-house allows them to rapidly design and test and print new parts. So it's a prototype machine that makes end-use parts. This results in better and more optimized designs. So overall, once they brought their Metal X in-house, they reduced their lead time from weeks to days. And within a year of having the Metal X, the company paid for all of its machinery alone, paid for the printer and all the costs to run it. They were able to then get their products to customers at a faster and more affordable rate, and saving about 86% of their lead time. Got a couple more for you. So Wärtsilä services a third of the world's largest cargo ships and oversees the manufacturing of large engines. Their Finnish and Italian factories often need to fabricate tools to solve problems and optimize the efficiency of both the field and the factories, and they usually have to rely on third-party suppliers to manufacture them. They use their Markforged X7 printer to increase the efficiency and make quick design changes. So this is a lifting tool that you see here. They were already familiar with Markforged 3D printing, but they needed more throughput and capacity, which is why they upgraded from a desktop series to an industrial series with a much larger print bed. One of their use cases for 3D printing is this lifting tool that you see here, which is used to move heavy components like engines. They needed to transform a heavy, hard to transport tool into a lightweight part that allowed the team to increase its efficiency. So here's a video of that tool working. By printing the tool instead of machining it, lost a whopping 75% of its weight. The tool was actually awarded a CE certification, making it the world's first CE certified 3D printed lifting tool. The company saved not just money, but increased the efficiency of its operations. They also purchased a Metal X printer and have found a lot of success in printing metal grippers. So like you see, here's a video of the tool in action. And it's supporting all the weight of that very, very heavy engine piece. There we go. So now their tool weighs a lot less, so transporting it is a breeze. And they can also print these to be more conformal depending on what they're trying to lift. So it's a benefit overall. Let's get past this part. Whoop. Okay. And then finally, we have Goering UK. They're a Birmingham subsidiary, not this Birmingham, of the Goering Group in Germany. They're a manufacturer of precision cutting tools for the likes of BMW, Jaguar, Land Rover, and Airbus. And they're very well known in the industry. They were searching for new business opportunities to serve their smaller customer base in the specialty tool space. By adopting metal 3D printing, they were able to open up new revenue streams for these high-value customers. So what you see here is a tool that they actually printed out of, I believe, H13. The general process for tools can be to be created included the designs needing to be approved by the customer before they go ahead and start making the tool. A process like this can take up to 8 weeks. So smaller customers have limited time to wait for a new special tool, and they're unlikely to have spare tools just sitting around. To open up new revenue streams for smaller companies who couldn't afford to wait that long, the team started looking into 3D printing. They, I'll go ahead and start this video. They made it out of 17.4 on the Metal X printer, and initially it was just a simple prototype to prove out the design. After adding cutting tips, the tool was used as a reamer to cut some aluminum, and it worked just as planned. Now the company can provide low volume tools to their customers at a reduced price and have opened up new revenue streams for the business to service smaller customers. So that's the end of the examples and my presentation. If you're interested in coming and seeing our printers, I understand the issues that we're facing right now as a society. So I understand if you're trepidatious of coming in and visiting us, but if you make an appointment, you're more than welcome to come and see our printers in person, and we can schedule a live demo for you. Also, if you have any parts that you're curious to see printed in metal or composite and see if they'll work for you, go over to our website and fill out our print request form, and I'll help you print it, and you can test it and see if the technology is going to work for you. Also, further, if you have more technical questions that I can't personally answer, we can schedule a call with a Markforged applications engineer, and they can get you taken care of. So with that, I'm going to go to the questions in the sidebar. So somebody asked, what is required of the end user once a new material is released? Any cost to upgrade the system? Good question. No, there are no costs to upgrade the system. The system is designed to be able to print all future materials. So when they release titanium, there's no special upgrade you have to print it. It will work on the system that you already have. And then somebody asked the dimensional accuracy with the process. So we say about 2 thou is about what we're looking at. Now, one thing that we recommend, it's in the design guide, is your pieces coming out of the centering oven although they are not prone to warpage because of the process, it can cause discrepancies in your nominal values. So what we like to say is design your pieces with a bit of wiggle room and then machine the contact surfaces, your critical surfaces. So make sure if you have something that has a really tight tolerance, design your part not to fit with that tight tolerance right out of the machine, but rather with extra space and wall thickness so that you can machine it to your needed dimensions. So are there any other questions? All right. Well, I don't see any other questions. So I guess I'm going to conclude it here. I want to thank all of you for coming and spending your time with me today. I hope I answered some questions that you had and maybe made you think of a couple more. Maybe made you think of some ways you could probably use this technology in your own shop. So with that, I hope you guys all have a great day.